Hello YouTube, welcome to Analog and Digital Communication tutorial series. Today we are discussing line coding. In PCM systems, once we get a bit stream, the next thing is to send that bit streams into appropriate signals on some physical channel. So in other words, if we have a bit stream of 10110 which I've drawn on the page, we would want to send this signal over some medium. So how will a 1 look like and how will a 0 look like is what line coding is all about. Please understand, line coding can be divided into 3 categories, and we'll discuss all of them today. The first one is the unipolar line coding, and the key point in unipolar line coding is that 1 is represented by some voltage and 0 is represented by a 0 voltage. Then unipolar is further divided into 2 subcategories: unipolar non-return to 0 and unipolar return to 0. Now if I label this as 1 and if I label this as 2, I'll show you the difference between the two by drawing it on the graph. Now in unipolar non-return to 0, a 1 is represented by some voltage, so we'll assign a voltage to 1 and we'll keep that voltage for 1 for the entire bit time, and 0 is represented by, of course, 0. 1 again attains the value of some voltage, for example A by 2. So, but the fact of the matter is 1 stays at A by 2 voltage level for the entire bit period or bit time, which is TB is the bit interval, and 0 stays at 0 level. And unipolar return 0 is different from non-return to 0 by the fact that 1 will start from its assigned voltage level, which will be in the positive zone, but it will return back to 0 after half the bit interval. So it will return to 0, and that is what the acronym says also. And a 0 stays at 0 level. 1 again is starting from A by 2, goes back to 0 halfway in the bit interval, and 1 starts from A by 2, goes back to 0, and so on. So this is what unipolar line coding is all about. Unipolar means that out of the 2 bits, only 1 is polar. In other words, 1 has some polarity, and that polarity in our case is a positive A by 2 voltage level assigned to 1. The next line coding technique is polar line coding. Now what is the fundamental difference between unipolar and polar is that 1 is assigned some positive value, for example A by 2 in this case. 1 is assigned some positive value and 0 is assigned that some negative value. So in other words, if we assign a plus A by 2 voltage level to 1, we must assign a minus A by 2 voltage level to 0, and that is the essence of polar line coding, where 1 symbol gets one side of the voltage level and the other symbol gets of the other side of the voltage level. That is how I remember it, and that is how I suggest others to do. And similarly, we have two subcategories. One is polar non-return to zero and polar return to zero. Now if I assign it as 3 and 4, 3 would look something like this. This is 1, this is 2, and a 3 would look something like this. Polar non-return to zero. 1 will be assigned a plus a by 2 and it will stay for the entire bit period, and a 0 will be assigned a minus a by 2, will stay there for the entire bit interval. 1 goes back to a by 2, stays a by 2 for the entire interval of time, and 0 is minus a by 2. And if it was a return 0, 1 would start from a by 2 but will return to 0 after half the bit interval time, and then 0 would start from minus a by 2, would return back to 0 halfway through. 1 would start from a by 2, move back to 0. 1 would start from a by 2, move back to 0. 0 will start from minus a by 2, will move back to 0. So that is how you plot, that is how you do line coding for polar line coding technique. And the third and final type of line coding is bipolar line coding. Now in bipolar line coding, the first one is assigned a positive value, the next one gets a negative value, and these values keep on toggling for every alternate one. So the first one will get a plus a by 2, the next one will get a minus a by 2, the third one will get a plus a by 2, and so on. And we have two subcategories: bipolar NRZ, which is known as alternate mark inversion, and the second one is split phase, also popularly known as Manchester format. Now if I was to assign this as 5 and 6, so let's draw 5 and 6 here. A bipolar non-return to zero. The first one will get a positive start. A 0 is represented by 0. The next one will be represented by negative. The next one will be represented by positive, and so on. So as you can see, 1 is toggling between a by 2 and minus a by 2 alternately, and 0 stays at 0 level. And finally we have Manchester format, in which it is also known as split phase. 1 will start at positive, 0 will start at negative, but halfway through it will change its phase. So 1 will start from a plus a by 2, but during the half bit interval it will go to minus a by 2, and that is what the meaning of split phase is. So how do we draw 1 in Manchester? We'll start from a by 2, but halfway through we go back to minus a by 2. So the phase is splitting within the bit interval time. And 0 will start from minus a by 2 but will end in plus a by 2. 1 will start from a by 2, will end in minus a by 2. Again 1 will start from a by 2, will end in minus a by 2, and a 0 will start in minus a by 2 and will end in A by 2. So that is how you can send the signals, the bits, zeros and ones, by using different line coding techniques over physical media. And these line coding techniques are extremely useful. They have their own pros and cons that I'll not discuss in this tutorial. And I hope this tutorial was of some help. Thank you so much for watching this video. I'll see you around next time. Bye.